So let's try out our newfound knowledge of the line integral with an actual curve or line and a density function. So the C stands for curve, even though it is called a line integral. I like to nickname it curve integral. The S is related to the length of the curve. And this function, it can have multiple purposes, but we're going to let the function represent density. So the way we'll treat this as a formula, we'll have a density function rho of xy or rho of xyz, and then ds is the same as the magnitude of the velocity of the curve or line dt. This is a multiplication here. So I want you all to see that t is the acting variable for the problem, not x and y. So we're going to have to find out what to do about that. It's sort of like when we had polar coordinates, but our function was in x and y. We had to convert it to polar also. So here's the example. We're going to find the mass of a wire, and the curve r of t is t comma 1/2 t squared, and the given time interval is from 0 to 3. So this graph is actually a portion or a section of a parabola. And it would be in this direction if we were going to think about the direction of it. If t is 0, you'd be at the origin, the vertex. If t is 3, you would be at the point 3 comma 9/2. All right, so those would be coordinates of points. So that's our curve or our line for the integral. The density function, rho of xy, is given to be 2x. Now, to find the mass, of this integration, I need some other information. It says magnitude of velocity vector. Oh, well, I guess I need to calculate the velocity vector. What is my velocity vector if this is my position vector function? Well, the first derivative of t is 1. The first derivative here is t. And then I need the magnitude of that. That will be the square root of 1 squared plus t squared. This is that aspect of the integral. So I have a density function. I have magnitude of velocity. And I realize I am just missing some information. I don't have limits on my integral. That x cannot stay there. So I'm just going to draw myself, these little arrows here with some question marks. What is going on with those terms? So let's do some cleanup. First of all, I do know the t limits. They are from 0 to 3. Next, I do know a good bulk of what's in the integral. But what is x? Well, The density function refers to the density of anywhere in the xy plane. It says rho of x and y, all x and y values. All we care about is the density on the curve or line itself. And if we go back to the given information, this is my x value here, and that is my y value here. I only need to know what the density is at those x and y values. So since x equals t, that's t. All right, my students, I believe this can be done with just a little u substitution. Let u equal 1 plus t squared. And I think you're going to find that this one was clearly set up by somebody that was feeling in a generous mood. That is u. This is du. I end up with 1 plus t squared to the 3 power times 2/3. And t goes from 0 to 3. And that leaves me 2/3. 3 squared is 9. 9 plus 1 is 10. 10 to the 3 power. If t is 0, 1 plus 0 is not 0, it's 1. 1 to the 3 power is 1. This, my students, is the density times the distance, which equals mass for this strange little thing called the line integral. We're going to do another sample in the next video segment, but for this one, I think I'm going to just let it sit right there. You have your formula for the line integral. If that's a density function, then we can find the mass of a wire. We have a given line or curve and a density function. And the density function's x and y values come from the curve itself. We want the density of the wire. We set it up, and we really hope it's nice to integrate at this point. Otherwise, that could be some extra work as well. All right, until next time.